percent composition, that's another thing you can calculate out, is 12.7% carbon, 2.1% hydrogen, 85.1% bromine. What do I do with those percentages? Just make it a G. So we're going to have 12.7 grams carbon. We're going to have 2.1 grams hydrogen and 85.1 grams of bromine. That's the first step. Question says, what's the empirical formula, and then what's the actual molecular formula? So first we have to figure out the simple form, and then figure out what the expanded form is going to be, I guess you could say, the actual molecular formula. So we've already done the first step. What's the second step in figuring out empirical formulas? We've already changed percent to grams. Have to make it moles. So to make grams moles, what has to go on the bottom? What's going to go on the top if grams are on the bottom so that they cancel? Moles. So the top one's going to be moles carbon, then moles hydrogen, then moles bromine. Anytime you have moles in a parenthesis for chapter 9, is 1. Anytime you have grams in a parenthesis, it's the mass off the periodic table. We memorized carbon's mass as 12. Hydrogen's mass is 1. Bromine's mass, I don't have that one memorized. You're going to have to tell me. 79 point what? 904. So it'd just be 9, really. So 12.7, what math do we do for this? Divided by, because it's in the bottom, so 12.7 divided by 12. 1.06? Oh, yeah, keep as many as you can until the end. You should only round at the end. Was it 058 you said?
Yeah, 058, 3 indefinite.
Okay, I would go until it's either indefinite or a 0 myself. Okay, 2.1 times and divided by 1 is still going to be 2.1. And 85.1 divided by 79.9, 1.06. 5. Yep. Okay, so we have them all into moles now. What's the next step for empirical formula? Divide all of them by the smallest one. So which one here is smallest? The one for carbon. So divide it by itself and divide all the other ones by that same number. The whole reason we do this divide all by small step is because we want one of the answers to get to 1. So 2.1 divided by 1.0583 is, and it's going to be close to 1. Okay. Last rule for empirical formulas, crazy Christy talk, is, well, the rule is round like money. So then look at the money thing. We have 98 cents. If we bought something for $1.98, you would tell your friends it was $2. And if we had something that was $1 and a penny, you would just say you paid $1. So carbon's subscript is, this is for the empirical formula. We have carbon 1, but you don't write 1s in chemistry, it's weird. Hydrogen 2, and bromine 1. Oh, that's not a 1, that's an R. But the question also says, what is the actual molecular formula? So we need to figure that out. And in order to do that, we have to have, the formula for that is the molar mass of the whole thing divided by the molar mass of the empirical formula, and that's going to give you a whole number. You take that whole number and multiply it by each of the subscripts to get the actual molecular formula. So we already know the 190 that was given to us in the problem. We're going to have to divide that by the molar mass of what this empirical formula weighs. So the empirical formula, carbon is mass? 12, and I have one of them there. Hydrogen, the mass is 1, and I have one of them there. I lied, I have 2 of them. I'm a liar. And bromine, I have 79.9, and I have one of those there, so 79.9 plus 12 plus 2, 93.9. Sounds like a radio station. So do 190 divided by 93.9. So really you're looking for a whole number, so that'd be 2. So you take that 2 and do what? 2 is not the actual molecular formula.
You times all those by 2.
2 is what you times each subscript by in the empirical formula. So we have C, 2H, 4Br. That's the actual molecular formula for that compound.